Hi everyone, my name is Jake Hafley, and today I want to kind of walk through how I made the motion controlled robot arm. So I've got it back here. It's kind of a big thing, so I probably won't be grabbing it much, but I might use it just to reference like the different joints and stuff with the CAD model that I did. So yeah, let's kind of talk about some of the goals. So I want to create a robot arm that uses four different servos for movement. I wanted to use a motion sensor and a flex sensor to control this movement. These sensors would be attached to a glove that I would wear to basically get the input data to make the arm respond. And so that's what you see with this arm right here. So up top here on the finger is the flex sensor. So basically as you bend it, the resistors go farther apart, and so the voltage value increases. So you can use that to basically make the servos respond. And so that's what I used for the arm back here, or for the gears. So then basically when they're pulled apart like this, and then when they shut kind of like this, and you could see that probably a lot better in the demo. But I also want to use different arm joints to be designed and printed with 3D printer and CAD software. I do kind of want to go through Fusion 360, the CAD software I'm using, and there's a feature where you can kind of play through the whole design, and I kind of wanted to show off how I did some of that and maybe give a better explanation. So the robot will be able to pivot at the base, move up and down, move forward and backward, and clamp down. And the flex sensor handle the clamp, and the motion sensors will handle the other movements, kind of like I said. So, section one, I kind of just wanted to get a rough idea for what was going on. So, I wanted to kind of start my CAD design. I figured out with just starting with the base and trying to figure out how to connect one servo at all would be really helpful, because I had to do a lot of test prints to figure out how I could connect the servo to different pieces and how I could screw it into different pieces. And I learned a lot about like threading screws and connecting electronics more permanently to these. And I wanted to test out one servo, and so I wrote some code for just testing out the servos. So here's this program. You have to define the digital pin that the servo is going into. You have to include this servo library, and then you have to make a servo object with whatever the servo is named. You have to run the attach function on it. So then basically, since I made servo 1 here, I have to attach it with servo pin 1. So then basically this first servo is connected to digital pin 3. And then I have a loop here where basically the position just increases. It's delayed by 10 milliseconds and the position increases. And then when you call servo1.right, it basically, from 0 to 180 degrees, it basically changes to that degree angle for the servo. So then you can screw things onto it and then change the right, and then it'll basically move it around. And I'll explain more about that later. But so this was kind of the program I used to, let me zoom in a little here. This was the program I used to test the servos when they were just plugged into the Nano, and I kind of built on this for my final program. But so over here are some pictures. So this first one is kind of a really rough pinout like circuit diagram. I was waiting for my parts to come in, and I kind of just wanted something to do, so I figured I could do a pinout of the servos and the sensors just to get an idea of how they would all connect on the Nano, since it's a little smaller on the breadboard. And over here are some of the test prints I did to connect the first base part to a servo. I kept the pieces pretty small because I just didn't want to waste plastic on the joints. And then over here I have one of the test servos connected to one of the battery packs, because you need the 5-volt power to be separated, like I said in my demo, from the Nano's 5-volt, just so you don't damage the pieces. To reflect, it was first time making a circuit diagram for the project. I really like doing this. I kind of like doing it by hand, but I know there's definitely better ways to do it with like computer software. I haven't really learned about the best ways to do circuit diagrams yet, but maybe that's something I could look into in the future, or I'll probably learn in school soon. I wrote a test program for servos and sensor inputs, went pretty smooth. I guess I can also show. So here's the code for the flex sensor. It's really simple on its own. If anything, I think connecting the wires for the flex sensor is a little harder, because you just define, it's an analog pin that it goes into. You set the pin mode by basically just putting the pin and saying it's input. I opened up the serial port so then I could see the values, And then I made a variable, basically read what was coming from the flex sensor, and then I printed that to the serial so I could see what the value was. So I think the normal value is about like 640 or 650, and then when you bend your finger, it goes up to about like 670 or 680. So then I just made the threshold one of those higher numbers, and then basically when it passed that, the servos like clamped in, and it was really easy to use. But since there's only 2 pins and they aren't like defined as like ground and 5 volt or like analog, so you kind of have to do a thing on the breadboard where basically one of the pins goes into ground and analog, and then the other one is just like a 5 volt. And there's also a resistor on it, and you can use different amounts of like ohms in a resistor to basically control how sensitive the flex sensor is. I just use like a 220k ohm one, which is what the tutorial recommended to me when I was looking up info on it, and it worked fine. There's enough of a gap to where, since I'm only doing basically like a binary on or off, I didn't have to be super specific with my input. Now, if I was doing something where it's scaled with how I basically grabbed it, I might have done that. And I could have done that, but I think for trying to grab things, it was a lot easier to just do an on and off type of thing. Had trouble getting screw sizes right to connect with the servos, but got it after about 5 small changes. So I had a lot of issues with designing the holes in the threads, and it made it kind of tricky. Going back, I probably should have used the screws that came with the servos to save screws and just found the sizes for them, but I didn't know the size and design of the screws. So I might just use those next time and look them up for whatever I do next. The bottom servo will mount to a circular plate to turn the robot arm. 2 other servos will be joints on the arm, and then 1 will be the clamp, and I've kind of gone through that a few times. We'll have to center the servos when they are positioned at 0 degrees before mounting the parts. So basically, when I was like screwing them in or connecting them to the different printed parts, I had to make sure that they were positioned at either 0 or 90 degrees, because to make sure that they could rotate evenly, like both to 180 and to 0. Because if I didn't position it right and put it initially at 0 and it tried to go past that, it physically couldn't, and then it meant that it couldn't turn one way. And so that wasn't too tricky, but I just had to remember that, or I might have wasted a servo or had to redo it. Section 2. So doing and completing the model. So I need to basically just design the base pivot, the arm portions, and the clamp for the separate servos. I want to make each part easily accessible to put together with the screws. This was mostly okay except for one situation, which it was kind of a problem. Figure out a way to attach the sensor components to the glove. I ended up just using electric tape to basically tape the flex sensor on the top of the glove. It made it really easy to just bend the glove and it went with it. I ended up just using the adhesive on this mini breadboard for the glove, and that worked out well. There wasn't any issues there. It still sticks, and that's probably about after a week of it now, and that works really well. I wanted to design a base to put the Arduino breadboard and a glove stand for, and that's what this is all sitting on. I kind of wish I made another piece, because when the Arduino isn't on, the arm just kind of falls down since there's no power to it, and I kind of wish I made like a little cover or something, because right now it's a little hard to give it support because it just kind of falls over on whatever it's on. But it's not a huge issue. You just gotta be careful of it when it's coming down. So here's a picture of the final design, and here's a picture of me. Oh, what am I doing in there? I think that has the little mini breadboard and the components connected for what we're going to go on the glove. And so to reflect, I used an add-on to make the gears for me, which made making the clamp much easier. So this was something that was in Fusion 360, so it made making the gears a lot easier, and I just had to rotate them enough so that they would basically connect together and rotate. Because if I didn't change the angle on them, basically what would have happened here is, as you can see, like one's a little offset. If I didn't offset it, then these 2 clamps would not have lined up well. They would have been off by like about 10 degrees. But yeah, and we'll come back to this guy in a second. I kind of want to show me like building it and do some cross sections. But I The clamp is made of 2 gears, one side servo, the other is basically just connected to the arm, so then it's kind of loose. Fine-tuning the dimensions for the screws and joints is very tedious, but I got them locked in over time. I still think I could improve on that a lot more. I'm definitely gonna mess with that a lot more before I do my next project, just to make sure that the screw holes really, really work. I use an add-on Fusion 360 for the gears. Some of the servos I ordered didn't end up working, so I had to order new ones. This kind of frustrated me. I got some cheap ones on Amazon, and 3 out of 4 of them didn't work, so I had to order 5 more, and all those ones worked. I just got a bad batch. It wasn't a huge deal, but it did kind of give me a time loss because everything right now is kind of tied to that 2-day shipping through Amazon. I use electric tape to connect the flex sensor to the glove, and I use the breadboard adhesive to connect the MPU and the breadboard. So before we talk about kind of the code and the different prints more, I kind of want to talk about this. So how I kind of work through this, we're doing these analyses. They're called section analysis, and so basically you can do these in Fusion 360 where like on a certain plane you can like cut into that basically just that plane and the object and push into it, and you can kind of get like this cut in your project. So like this is kind of how I used to design this inside part here, because you have the servo kind of linked on this top part, and you have a hole for the wires to come through, and then through this outside part and to be thread to the breadboard. So this was something that's really important to designing this, because it made getting in here a lot easier, and it just looks kind of cool. I think it's really cool to just get this kind of half cut in here. And there's also like another one in here, so then I can design this kind of circle hole for the servos in here. And then the only thing that drives me nuts is when I imported one of the battery packs, these pieces never moved. But down here, you have the 4 AA batteries, the 9-volt battery, the breadboard. There's an Arduino Nano on here, but it presses into the breadboard, so I didn't actually ever need to import it because I just needed some rough dimensions for the base. And then this is where the glove's at. So I'm pretty sure, here's like all the changes down here that I've done for the project. I kind of want to see, I'm pretty sure if I just hit play, we can kind of watch everything from designing it. So this is me designing the first servo. You can't really see it, but in there I was doing the holes in the threads. Here's the plate that basically rotates, and then I added some little screw holes to basically mount it so then it wouldn't move a bunch. I kind of did a rough size estimate for the arm, and then I did some bases to basically support it. You can kind of see up here I'm adding the next servo in. You can't see fully what's going on in there, but I'm basically adding a hole so the other side of it can basically have a piece that supports it. I ended up adding another servo in there because the weight wasn't enough to support it because this part was so big. If I was going to go back, I probably would cut some holes in these pieces because it's just a lot of plastic and weight, and it made it really hard for the servos to support it on these 2 joints here. Since it had to basically carry the torque of this entire arm. And this piece was fine, but this piece was basically double it, and even with the 2 servos, it wasn't enough. And then here you have this kind of rough base plate. You got the glove holder. It looks like I'm working out over here. I had to make a little extra space on the side, so then the servo and the gear could fit well enough. I was going to put them on the top, but I kind of liked how they were on the bottom more because it kind of hid what they were doing, kind of with the servo and stuff, and it made it so the wires could come out easier. I was a little worried about how much wiggle room. I thought this piece right here would be too flimsy, so I kind of extruded it out a bit to kind of match right here, but I didn't on this side because, like I said, worried about weight, and that was a good worry, but I should have optimized it a little more. But yeah, so that was kind of a walkthrough of, it looks like I've saved this 26 different times, so it's been a lot of different iterations over the last few weeks. I was really close to wanting to redesign it and just kind of do a whole version 2 with everything I learned, but at this point the project was kind of done, and I figured I could just kind of chalk it up as learning and maybe just apply this better into what I do next, because I don't know. At this point, like the project was 95% done. Every piece was printed. I would have had to wait like probably 5 days to print everything out again, and just it seemed like a lot for minor improvements. When I could just be putting that time towards learning new stuff and applying new stuff, while still applying what I learned into something new. But maybe I'll come back to it and redesign it better. The issue that was for the most part was, so I made these tiny little holes for the screws to go into the servos, because right in here is like a servo, like we saw earlier. I can pull up another analysis. So like in here's the servo, right? So right here, it was this tiny, tiny little screw. But the issue was it was breaking through the plastic because it was like 0.5 millimeter thin. And it basically made it so it was really hard to rotate. So for my next project, I'm going to use the little plastic arms that they put on the servos and basically just set those inside of these pieces so that there's more support. But I definitely need to look into better ways of doing that because it kind of just digs into it. So I need definitely some type of stronger way to do that. So I'll definitely be conscious of that going forward. But yeah, so that's kind of the model. It's really cool. It's definitely a huge step up from what I did before. The LED strip thing was kind of getting my feet wet with 3D printing and modeling, and I feel like I could whip up that little box thing in probably like 5 minutes now. But this one's a lot more complicated. There's a lot of different working pieces to this and a lot of more management like with the parts because I kind of chunked it up based on the servos. Because like this is all servo 2, and it's nice because you can kind of take this parts away. But then there's also like different components like the servo, the base, the arm, the second part of the base right here. And it's all kind of just broken up, so it's easier to manage. And this type of detail is really important for these models because if everything's kind of clumped together, it makes it really hard to make small changes sometimes. But yeah, so that is that. Section 3, connecting the code and the prints. So I needed to print off all 8 arm pieces. Most of the time I could do small, like I did like 2 of them in the day, and then I printed like the long ones overnight. I needed to connect both the battery packs to the breadboard, servos to the Arduino, the sensors to the glove, and then connect these sensors to the Arduino, and then connect and write the final code. So let's kind of walk through some pictures here. So here's a picture of all the separate printed parts. Here's me connecting the arms here and the base to the bottom, and then here it is kind of final and all together. So I ended up using a MPU library, so a lot of the code in here is about smoothing out the data, and I used a lot of this from like an example library. So you can see some of my code here, like the servo pins, the interrupt pin, the flex pin, the servos. But like all this stuff here is basically to help control smoothing out the data and making the data from the motion sensor a lot easier. And so I basically just used this library to help me do that. And so basically in this loop, like all the code down here, it gets the yaw, pitch, and roll, which are the different rotating like angle axes. So like it'd be like left, right, it'd be like this, I'm going to be like this. So I use those different inputs to basically control the sensors, which is the code that I wrote here. And then also down here, just so the yaw, pitch, and roll are basically getting inputted the same time as the flex sensor, I put this like analog read for the flex value down here. So basically how this works is every time that the MPU can read more data, it jumps into this like if else like condition down here, or this while condition. But every other time while it's waiting to get data, this loop just runs, which is basically just the if else checks for all the different servos. And so I use this function called map, which is extremely helpful. This is a really good way to basically make a range of data into another set of a range. So what I do is I check like if the yaw, so this is checking if servo 1, the base plate, would move left. So basically say it happened if I like move my hand like this. And if I move my hand like this, the MPU sensor will go from 0 to some point between 0 and -60. and it can go past that, but I just made it -60 so your arm doesn't have to like go all the way around because that's just uncomfortable. Um, but then it makes it so you have the low value and high value, and it changes to another low value to a high value. So basically, what happens is if the sensor is normally at 0, then the angle of servo 1 should be positioned at 90 degrees because it's positioned there. But if it's all the way over at -60, it's going to be mapped to 180 degrees. So it can rotate 90 degrees over. And so basically, any number between those two ranges, it'll evenly basically convert it to be between 180 and 90 evenly. So then it basically, like the servo will evenly give the right amount of degrees to move. And so it smooths out the data really well. So you don't have to worry about how much the servos are moving, because like if you wanted to make it so the input was different, you could change these first two numbers and the actual angle degrees wouldn't have to change. And it makes it really nice because it smooths out your data from input to output really well, and it made the servos a lot less jittery and very smooth. And it was really nice. It was a really good practice to use that. And so this idea I kind of applied to all of them. So down here, I have it so if the flex value is greater than the flex threshold, so basically if you're squeezing your hand and the value is higher than the minimum for the servo to clamp in, then you make it so this last servo position goes from 0 instead of 90. So then that's basically how it goes, like this. So yeah, and then at the end of all these, I write all the servos with the positions. I had a 1D array for them since I thought it was just easier than doing separate variables. I just had to keep track of which servos were connected to which positions, but it wasn't too complicated. Helped me save a little storage. But yeah, so I ended up using the servo library and this MPU library. It definitely helped with a lot of the code. It looks kind of overwhelming with like how the library is done here, but it definitely helped smooth the data out a lot better, and it helped me not have to worry about that input as much, and I could just focus on making sure the servos were doing what I wanted to. But yeah, the code's not too crazy. It's really, this project was a lot more about connecting the 3D parts to the servos and designing that. But I really liked every piece of this project. I really enjoyed how the motion sensor and the flex sensors interacted with the servos. I definitely want to do more of that. And I still have a glove, and I'm honestly like, I might do like some type of Bluetooth input with a motion sensor to with the like the spider robot thing that I'm kind of thinking about doing. I'm not sure what I'm gonna do for the input for that yet, but it might be Bluetooth with the glove, which would be really fun. But so section 3, reflection. I had issues with the screws not being large enough on the arms, so I ended up hot gluing the servos instead. At this point, I kind of just took it as a thing of, if I didn't do this, I don't think the robot would have lasted very long, because the screws dig through the plastic and basically just get connected to the servos and they don't rotate as much. So I'm going to be more conscious of that going forward, but it was kind of a necessity just to get the project done, and so I didn't have to hard redo everything, because that would have sucked, but not the end of the world. But I just kind of want to keep trying out a lot of different things. So I think if I start something new, I can learn a lot more for that, and up with applying what I learned. Had to add a 5th servo on the top for the arm base since one didn't have enough power to move it. It still didn't have enough power, which was kind of frustrating, but I think the practice of doing that and the idea of doing that was good. I think it should have helped it. I think it still did a little bit, but yeah. So also need to practice designing and printing screws more for the next project, because that was a pain for this one. The main arm had trouble with lifting up so much weight, even with 2 servos, so had to adjust for that. So final reflection, I had a lot of fun designing a more complicated CAD model. I mean, last time I did something, it was a glorified box with different gaps in it, and Well, that was a really good way to get my feet wet. This one was really push my limits of it, especially considering this is kind of my first like month of using the software. I'm really, really proud of this. But yeah, I really like it. I love the applications of it with the 3D printer. It's really cool. There's so much I can do with it. It blows my mind. Um, Printing out the pieces took more time than I thought. This time it was pretty tedious. It was really hard when I like one little piece or of the screws like didn't work, and then I had to print off like the whole piece again. So I think for my next project I'm going to try to make more smaller pieces and try and make connecting them a lot easier, so then the trial and error process goes a lot smoother, so then I can maybe fine tune it better. Next time I want to try and make screw holes and threads easier to use. I want to incorporate plastic arms that come with the servos better for next project. So I want to like put the plastic arms on the servos and then basically like fit them around the servos. So then, or like fit my pieces that I design around the servo so they kind of lock into it. So then there's more support, and it isn't just relied on that tiny little screw drilling into it. But I think also another issue is like the gears didn't really like fit, and I just kind of made circles, so it just didn't really grip onto the servos very well. Um, and I'm really happy with how the flex sensor NPU turned out. I really kind of just want to do more of that with another project. This little robot spider idea I'm planning, I don't know what I want to do with the input for it, but that might be very well be the plan, just to make a um, put like a battery pack, a Bluetooth sensor, and an NPU, and maybe some flex sensors onto a glove, and it'd be heavier, but oh man, it'd be really cool to make like a little robot thing move around with that. I'll try to plan out the CAD model ahead better so I can save time. But you know, the plan if I do make this robot spider is to make it so that I have 3 servos each for each leg. And so if I can get the design down really tight for one leg, I can just mirror it across different planes to basically make the 4 legs, and then I can just make a central base to put the batteries and Arduino on, which I think the design for that honestly wouldn't be as bad. And I think it'd be easier to design and print, but we'll see. You know, things don't always go as totally expected, but that's okay because you know, you learn from it. But this is kind of my third hardware project. I think this will probably be the last one that I get done this summer. This is probably gonna be the last big thing, but I really enjoy this. I think this is kind of my niche right now. I really like this hardware stuff and designing it and just doing it all top to bottom. And I think I'm going to really try and still push for doing this in the fall. I hope to still document it. I don't know if I'll do it to this extent, but I definitely want to record like demo videos still, and definitely keep like a GitHub page open, and probably just do some stuff talking about it. But we'll see. It isn't super time consuming to like log it as I go. But yeah, so we'll see how that goes. But it's really fun. I'm definitely gonna keep doing it. I don't know when something else will be out, but hopefully at some point, probably in the next month or two. I'll get really busy again, but like I said, this stuff's fun. But yeah, so thanks for watching. This video is about half an hour long. It's a decent length, but if you got any questions or interests, you can read more about it on my website or leave a comment on this YouTube video if you go to YouTube site. But yeah, so thanks for watching again, and I hope to make something cool next time. Bye.